Hello, everyone, and welcome to the EBA webinar podcast series. On behalf of myself, Aaron Smith, and Nancy Bakeman, I'm pleased to welcome you. We've got a longtime partner today, Joe Nebbia with Newport Partners. Joe is the Building Science and Regulatory Analyst for Newport Partners, and we're really proud to introduce this series. I personally am really excited about it. It'll be an 8-part series. It'll be up at eba.org in recording on the EBA Academy, and we will be walking through how to comply with the Residential Energy Code. Many of you have asked for updates on the 2021 IECC. You'll find this within. We will have Q&A available for those of you watching live. Just put your questions in the Q&A section at the bottom of the screen, and we'll get those to Joe throughout the presentation. Joe, on behalf of EBA, we'd love to welcome you. It was great seeing you in Denver, and we're looking forward to spending some time with you over the next couple of weeks.
Great. Thank you, Aaron, and thank you, Nancy, and thank you to the whole team at EBA. I'm absolutely thrilled to be here talking today. I'm always thrilled to talk about the Energy Code, believe it or not. I find it fascinating. And I hope that you find this fascinating too. I think this is going to be a great opportunity to walk through the entirety of the Residential Energy Code, how it works, what the requirements are, and then also talk about the science behind those requirements and ways to do it maybe even better than code. So as Aaron mentioned, we're going to do an 8-part series, and today's class is on compliance paths, code structure, and the compliance process. And that might not be the most exciting thing to start with, but it is an important bit of information to have so that you understand the context of these requirements as you go through. I think of the Energy Code a lot of times as a puzzle, and you have to kind of find what pieces fit together for your construction or building, and yet it has to fit in a way that the code allows. And so we're going to start by talking about that structure of the code and how it works. The next module is scheduled for December 9th, where we'll start talking about window and insulation requirements. For climate zones 1 and 2, we're going to split it up by climate zones so that we can cover all of them. December 14th, we have scheduled the same talk, window and insulation requirements, for climate zones 3, 4, and 5. So that's more the middle of the country, mixed humid to slightly cold climates. And then after that, we'll be scheduling into January of next year and beyond. But the following module will be window and insulation requirements for the colder climates 6, 7, and 8. Module 5 will be insulation installation, both mandatory and prescriptive requirements, and the science behind those installation details and why they're important. Module 6 is air sealing, one of the more challenging aspects of the Energy Code. And so we're going to talk a fair amount about air sealing. Module 7 will be ducts, heating, cooling, ventilation, hot water, and lighting. And then module 8 we'll talk about the different performance paths in depth. Today, we're going to talk about those paths briefly and how they fit in the structure, but module 8 will talk in depth about those paths and also the new 2021 IECC additional efficiency packages. So that's the schedule. We'll have some more dates posted and out to everybody. And I hope that you'll come back for each of these modules, as I think you'll find them. I think you'll find that they'll build on each other and that you'll get a lot of good information as we go. Today, we're going to have a few questions for our live audience. For the recorded audience, I'm sorry you'll miss that. But if you want to just take a moment, you can actually access these questions and they will go live when I get to them in the presentation. This QR code, if you have your phone there, just hold it up and you can get right to these things, and just keep your phone open and it will pop up. The question will pop up when you get there. If you don't have a QR reader or you want to use your computer, you can go to this link that I have here. Don't try to click on it. It's not on your screen, right? That's a webinar. But you can type that in or just go to slido.com and enter 772767. So QR code's easiest if you've got a QR reader, or you can go to slido.com and 772-767. These will come up also as we go to each question, but if you're, as we're talking here, getting in, it will allow the question and answer part to go a little quicker. So I'm going to leave this up just a moment longer. Hopefully this makes it a little bit interactive for you, and it will also give me some feedback about whether we've gotten the concepts through well to you. So I'm going to start a little bit before I talk about the compliance paths, just talking very briefly about some building science basics. Most of this audience, I think, probably knows this, and EBA has quite a lot of really great content on this, and I encourage you to look at all of that content at a different time. I'm just going to hit some really high-level concepts to talk about what the Energy Code is thinking about when it has all these requirements and why the Energy Code is here and what it's trying to do. So again, very basic stuff. Most of you, I'm sure, know this, but the basic thing that the Energy Code is trying to accomplish in most of its requirements is the control of heat movement. And that the type of heat movement that it's trying to control are conduction. That's, obviously heat moving across surfaces by touch. So if it's hot outside and your wall is there, that heat will want to move across the building envelope. Heat always moves from more to less, right? So if it's hot outside and it's cold inside, that heat will want to conduct across that wall unless we find a way of stopping that heat movement. Convection is heat movement through the air. And then finally, radiant heat movement, which is how the sun is heating the earth. And those are the three different ways that the code kind of looks at controlling heat movement. And I'm being very basic here, but that's essentially what the code is trying to do. From a conductive heat movement point of view, the code is requiring things like insulation in our walls, attics, floors, in order to stop that heat movement. So if it's winter and I'm warm inside and cold outside, the heat wants to escape, and we put insulation in to stop conductive heat movement. That's the purpose of insulating. And when we think about code requirements, that's important because sometimes there's some products that get kind of marketed out there as insulators, and they really don't stop conductive heat flow. And so it's important to remember that the code, when it talks about stopping, when we talk about putting insulation in, the purpose is to stop conductive heat flow. Different ways you can do that, there's a lot of insulating materials. We have rigid foam down on the left, fiberglass bats are up on the top left, spray foam insulation in the middle there. And then also our windows stop conductive heat movement as well. Glass is an insulator, and although it doesn't insulate as well as, say, fiberglass or rigid foam, it does have an insulating quality to it. So when the code talks about stopping conductive heat movement, and this is an important concept as you try to understand how to comply with the code, it deals in two different concepts. One is R value, and that's the resistivity of a material to conductive heat transfer. So an insulation will have a labeled R value, and that tells us higher is better. The higher that R value is, that tells us that the insulation is better at stopping conductive heat transfer, or that the more insulation you have, the more resistivity to that conductive heat transfer you have in some cases. When the code talks about R value, it's talking about labeled R value. So if I have a fiberglass bat that says R21 and I install that correctly, according to the manufacturer's instructions, that bat has an R21 according to the code. It doesn't mean anything about effective R value. So if you hear the term effective R value for code, there's something a little bit off. So I see this a lot of times with the foil-faced bubble wraps, where the manufacturer says, this has an effective R value of R10, and it's like a 1/4 inch thick. And I'm thinking, well, why are we insulating with this all the time if that's the effective R value? And you look at it, it really doesn't work that way. It's a radiant barrier that needs an air gap that's perfectly installed, and it's got to be facing the right way, and it never is facing the right way when they're using it as an insulator. Anyway, that's a little bit of a tangent to the point is that we're talking about labeled R value according to the code. It's also not talking about air sealing, and it's not talking about things like framing factor. Framing factor comes in when we think about U value, and U value is the inverse of R value. U value is conductivity, how well heat transfers across, and lower is better. The code, when it talks about U value, it's either talking about windows or it's talking about the whole assembly of a wall or a ceiling or whatever. So if an insulator says my wall product has a U value of such and such, it's talking about the whole wall assembly when we're talking about code compliance. And there are different tables you can use depending on whether you want to use labeled R value or effective U value, which is what that U stands for. It's taking into account the entire wall. How much wood do I have in it? Is there no wood in it? These sorts of things. That's important from a code compliance point of view, and it'll help you keep those two concepts different. I'll go over them briefly again when I talk about the insulation and window requirements in future modules. Convective heat movement, this is air movement because of pressure differences, because of wind, these sorts of things. And the way we deal with that in the code is by air sealing. And there's a big section on it, and it's all required. And it's one of the more stringent parts of our energy code is the air sealing section. So we're trying to control convective heat flow with air sealing, not conductive, convective. And we might use something like spray foam insulation also controls convective heat movement in some cases. House wrap and building paper, things like that, caulks and foams, tapes. These are all things that stop air leaking across a building assembly. So that's convective heat movement. And finally, radiant heat movement. The main way we control that with the code is by overhangs, solar heat gain coefficient in our windows, shading, things like that. That's primarily how we control radiant heat movement from a code perspective. Radiant barriers don't really play much in the residential energy code. There are some climates where they're effective at controlling radiant heat movement. A lot of the US they're not, but the code doesn't really do much with radiant barriers.
Joe, a question came up on what is dynamic glazing?
So dynamic glazing is a glass. You don't see it often in residential applications. You see it sometimes in commercial, but it's a glass that will essentially shade so that it shades itself when a certain amount of sunlight is coming through. So it's essentially a lighting control or effectively, so that if too much sunlight is coming through, it shades, and then it can stop some of that radiant heat movement sometimes. But again, it's, if you think of it like if you have glasses that
it's like the transitions lenses, but for your house, and the window either through thermal or electronic control can change its solar heat gain coefficient profile.
That's right. Very good.
I may have worked for a dynamic glazing manufacturer in my past.
There you go, Aaron. Well, you should have just answered that from the beginning, but because that was a much better answer. And there are also dynamic shades to some extent. Sometimes, you can get shades that will shift with the sun. Again, you don't see these too often in residential applications, but that is a way that you could control radiant heat movement in the house through shading.
Great, thank you.
Great. Okay, I think we have our quiz here. So I'm going to give everybody a moment to get in. Again, that QR code is there. If you want to go to the website, you can start to type it in there, and there's a code. Hopefully a lot of you got in at the beginning when I brought this up. But the question is, which of the following help to control conductive heat flow across a building envelope? We did just talk about this, so hopefully I got through to some folks, but there are a number of options here, and you should be able to see them on whatever device you're using. You can enter your answers. There's multiple correct answers and some that are not correct. So please pick the correct ones, and I will move on in just a moment. I'll give you a few moments to get there.
Joe, I think the trick question there is paint. Sorry, and I don't want to give away any answers, but I just got some information from my architect on energy saving insulating paint.
And you think it's real?
I don't know yet. I was going to ask you.
Unlikely.
Okay.
So just gave away
I maybe gave away an answer then.
Okay, everybody's getting it right.
Perfect.
Most part, foil face, bubble wrap, caulk, and paint do not stop conductive heat flow. Paints, sometimes reflective paints are marketed as, again, a R value adding product. They don't really add R value. They can work in some climate zones, probably not Connecticut, Aaron. What they do, what paints can do is they can help with air sealing. So if you have a block construction or something like that, certain paints will help you to seal up that kind of porous material. And in fact, in the commercial energy code, you see that as part of air barrier strategy compliance. But I would be hesitant on any paint that's advertising an R value.
Thank you.
Okay. So now we're going to get into this, the structure of the code. That was the main topic here, and we're doing well on time, so that's good. The code has a number of climate zones, the energy code. So one of the important things to start out is to know what climate zone you're in. And these do change from code edition to code edition. So in 2021, there were a number of climate zones, I believe in Western New York, that changed from 6 to 5. There are a few other shifts in climate zones. These are all done by county. So if you know what county you're building in, you can look in the code. There's a big map, but then they have each county in the country listed in the table, and you can go and find what climate zone you need to reference. This is going to be important because it's going to determine a lot of your energy requirements, insulation and window requirements, these sorts of things, by climate zone. So it's important to know where you are. Climate zones 1 through 8, the higher the number, the colder your climate zone is. I'm here in just south of Baltimore. I'm in climate zone 4, and I'm in a 4A. And what the ABC mean is A is a humid environment, B is dry, and C is marine. And C is really just on the West Coast. Parts of California, Washington, Oregon are in climate zone 4 and 5C, 3C in some cases. In California, 3C, but that's how those climate zones work. And so you look and you see where you are related to the temperature and then also the humidity, and that's how the code is organized. Climate zone 0 is a tropical zone. So think of like US territories in the Caribbean. This would apply to them, parts of Hawaii, possibly. So tropical is now its own section in the 2021 IECC R407, and it has its own specific requirements that are totally separate from the rest of the code. So if you're coming to this webinar from Puerto Rico or US Virgin Islands or one of these places, the tropical zone is what you're going to look at, and it's R407, where you're going to find pretty much all of your code requirements, as opposed to the other climate zones where they have what we're really going to talk about next. So in the 2009 and 2012 IECC, International Energy Conservation Code, and I know I should have said this at the beginning, a lot of you have local codes, maybe you've got the IECC, but it's amended, maybe you have your own state code that's not IECC based. So this is based on the National Model Code. So some of your local requirements might be slightly different, and it's important to check those. But 2009, 2012 IECC, again, you find your climate zone, and then in each of those codes, there's a number of mandatory requirements. That means regardless of my compliance path, I have to do these options in order to comply with the code. And they're marked in the code as mandatory. Each section says mandatory if it's mandatory. After the mandatory items, you then have some options. You can use prescriptive compliance, and that's kind of like a checklist. It's, I do this list and I comply. Or there's section R405, which is simulated performance alternative. And the simulated performance alternative is a whole building model that's based on energy cost. And the concept there is I do all the mandatory items, and then I design a home that is equal to or less than the energy cost of a home that's built to all of the prescriptive minimums. And my home gets compared against those minimums. So in 2009 and 2012, those were our two options: prescriptive or section 405 energy cost budget trade-off. Now, we'll talk a lot about section 405 in module 8 of this training series when we go in depth about how it works, what you can do, what you can't do. But for right now, you know that there are those two basic options in either 2009 or 2012, if that's what you have adopted at your local level. 2015 and 2018 have another option. So again, you look at your climate zone and find that. Then we have to do all the mandatory items. This is the same as 2009 and 2012. But now we have 3 compliance paths options. We have prescriptive compliance, we have section 405 simulated performance alternative, and then a new section was added in 2015 called the Energy Rating Index performance path, R406. And an energy rating index is similar to a HERS index, if you know HERS index from Energy Star and these sorts of things. But HERS was a proprietary way of measuring. So ResNet got together and created a ANSI standard. However, in 2015, when this path was introduced into the code, the ANSI standard wasn't finished yet. And so IECC, when the code change was put in, they had to say energy rating index because IECC can only reference consensus standards. So there's this new path called an energy rating index. It's a 100-point scale like the HERS index. 1 point is worth 1% reduction in energy compared to the 100, just like the HERS index. The HERS 100 is a 2006 IECC home, just like the HERS index, but it's called an energy rating index in 2015. In 2018, they actually referenced the ANSI standard for ANSI 301 for energy rating index. And they also introduced a change in the energy rating index that tweaked how the ventilation rates were measured in an energy rating index in the code, which means it's still slightly different than a HERS index. Also, the HERS standards, ANSI 301, are constantly updated. They're on a continuous maintenance process where changes are introduced and then they're included in the new version of the standard. The code has to reference a specific version of ANSI 301. And so that code energy rating index might not be exactly the same as your HERS index at all points. And it doesn't matter to a big extent, except that from a compliance point of view, you have to hit the energy rating index. Some of the voluntary programs like Energy Star and Zero Energy Ready Home are starting to use the term energy rating index to be more consistent, and they're referencing a specific standard year for that measurement for their compliance processes. But from code, it's just the energy rating index that's available there. So you now have 3 paths in 2018 and 2015. From a prescriptive compliance point of view, there's also flexibility. So prescriptive was that checklist, right? I have to do the mandatory items, and then I basically do everything in the code, but that doesn't mean that the code is without flexibility. I talked a little bit about this before. There are insulation R values, so that's a labeled value. I know that my rigid foam board is R5 per inch and I've got 2 inches, so that means I've got R10. Or I've got an R21 back of insulation in my wall. There's also assembly U factor, and a product like a SIP wall might use this to comply, or an ICF, insulated concrete form wall, might use this to comply, because let's say I need an R20 and my ICF has 2 continuous rigid foam boards that are 8 each. Well, very likely I will comply with the U value assembly, because it's continuous insulation. It gets a better U value. It's uninterrupted by framing. So for a product like that, I might use the U value as opposed to the R value. There's also the whole building UA, which is U value on an area weighted average. So think of it like I have a house and I don't want to put in as much insulation in the walls as the code calls for. So instead, I'm going to put more in the attic. And as long as on an area weighted average, my U value equals that U value that the code would require, then I can comply. So it's not just the wall that I'm measuring, it's the entire building envelope: windows, walls, ceilings, floors, everything. So those are the 3 different compliance paths within prescriptive for doing my insulation. I often hear people say, well, I'm doing the res check path. Res check is not a compliance path. Res check is a compliance tool that Department of Energy publishes. It is updated for the 2021 code. And it will do a UA calculation, a whole building UA calculation. That's what it's basically used for. It's not a compliance path. It's within the prescriptive path. You're doing a UA calculation on your building envelope. You still have to do all the other mandatory items in the code. So that's an important item to keep in mind there. That's what the code has looked like until now. This is what code looks like in 2021 IECC. And I'm going to show it to you in a couple of different ways, because it's important to understand how complex this code is. And I don't say that for any other reason other than to tell you, you have to pay attention with this code, because if you think you know what applies to you, there's probably a different section that also applies to you in the 2021. So if you see over here, we have our 3 different options. Prescriptive compliance option, I'm just calling it that. You know, they've gotten rid of in 2021 the language prescriptive and mandatory. That language is gone now in 2021. So everything that we used to do in previous things, we do mandatory requirements and we do prescriptive or performance. Now there's no such thing as a quote mandatory requirement. It's either required in each path or it's not. So prescriptive compliance, you're going to do what is the bulk of the code, 401 to 404, and then one additional efficiency package. That might be efficient hot water, it might be efficient heating and cooling, it might be ducts and conditioned space, it might be super air sealed along with balanced ventilation, it might be a number of options. I think there are 6 or 7 of these additional efficiency packages. So for prescriptive, you just have to do what's in the code and then one extra thing is essentially how it works. For total building performance option, this is that simulated performance alternative that was an energy cost budget trade-off. It's now allowed to be either energy cost or energy use, and we'll talk about that again more in module 8. But you're doing a performance calculation. There are portions of 401 to 404 that are required, just like we used to have the mandatory items. They're not called mandatory, but this section points back to them. And then section 405, you either have to do one of the additional efficiency packages or make your home 5% more efficient than would be required in section 405. So you have a performance option or one of the additional efficiency packages. Energy rating index, that's that R406, still called the same thing. Again, we have portions of 401 to 404, those things that were called mandatory that aren't anymore. And your energy rating index has to be 5% better than the one listed in the table. Now, why they didn't just make the table what we have to shoot for, I'm not quite sure, but that's how the code's written. Those are your 3 paths, and they look a little bit more complicated. I'm going to show you they're even more complicated than this depiction here. This is an example. I'm going to show you some examples of the tables in the energy rating index path that say what we used to call mandatory, what's required. So we have to hit this energy rating index target on a whole building performance level. But there are also a number of tables that say what sections of the code you have to do if you're doing section 406 as your compliance path. So if you look here, a lot of these items were formerly mandatory. The certificate, code certificate, mechanical piping insulation, parts of the duct sections were mandatory before, air barrier testing, these things were mandatory. You have to do all of these things, right? There are some things that were labeled prescriptive in earlier versions of the code. Attic hatches and doors, those details, eave baffles, those weren't called mandatory before, but they're required in all of the compliance paths now. So there are more things that you have to do. You can't trade off depending on what path you're in. Now I'm going to show you where it gets a little complicated here. This is more of the table. Mechanical ventilation, different controls if they're applicable are all mandatory. Again, we'll go into this in more detail in module 8, but I'm going to go back to that first part of the table because this right here, the air barrier and insulation installation table, this has been mandatory in the code for quite some time. So regardless of your compliance path, you have to follow this. And it has details on air sealing and also how the insulation has to be installed. Things like your thermal barrier and your air barrier have to be in continuous alignment. Things like you have to cut narrow bats to fit rather than compressing them. Different things that have to be air sealed like hot plates and sill plates. All of these things were in this table. But this table now contains, in addition to all of the details it used to, new details on foundations, including basement insulation and slab edge insulation. It's important to point this out because those were things that were prescriptive in previous codes. So, for example, if you didn't like the fact that the code said my basement insulation had to go to the floor, you could use the performance path and that detail wasn't required according to how the code was structured in previous codes. In the 2021 code, what happens is you're here and you see this whole list of sections that you have to comply with. And then you go to this table and that table now points to other sections that you have to comply with. If you're confused, that's good because the point of this is you have to pay attention to all of the code in the 2021 or you're going to miss something you were supposed to comply with and possibly have a problem at inspection. have a little asterisk here on the slab edge because actually the table references 402.2.10 for slab edge, and 402.2.10 is now the crawl space insulation section. So it used to be the slab edge, and a whole bunch of code changes happened and things got mixed around, and the table is referencing the wrong section. But clearly we're not trying to tell people to install crawl space insulation details at their slab edge. It's a different approach, right? So I expect an errata out on that item in the 406, or I'm sorry, in the air barrier table. But that's the intent of the code, is to reference those sections. Now I'm going to demo here, if I can just jump to a different platform. Hopefully you all can see that here. This is my visual. What's that?
Yeah, we see it fine, Joe. Thanks.
Okay, great. This is my visual depiction of what I think the compliance paths look like. And if you look over on the prescriptive path, everything in yellow is just what you have to do, right? There's some flexibility in whether you do R, U, or whole building UA for your insulation. You can trade off windows on an area weighted average, that sort of thing. But for the most part, you do everything. The other paths get a little bit more complicated, and I'll look at 406 because we were just talking about that. Everything in purple I have here in the right column, and don't worry about the details too much, is what used to be mandatory and what's now just in that table in 406 that says, here are the sections you have to comply with. So if you look down, a lot of these sections, things like what you do with your insulation around plumbing and wiring, these were mandatory before. But these sections, as I just talked about, point to other sections. So if you look here on the screen, and I'm at the air barrier and insulation table, this section here now points to several other sections in the code. So I go down and I say, okay, here's all the sections I have to do, but then I catch these and I say, wait a minute, I have to go back and do these other sections as well. And that's the floors, the slab on grade, the basement insulation that weren't in that table before and now are. So you almost have to follow the code through and then backtrack to see what sections apply if you're using one of the performance paths. It's not easy, and that's why I'm kind of stressing this over and over again. Again, we'll talk more about what you can actually do in the performance paths in Module 8, but I want you to know that in 2021, it works differently than it has in past codes. And you'll find that if you don't look at the code in its entirety first, you will miss some things that are in fact required when you thought they weren't. Now I'm going to go back here into our presentation. Hopefully everything will work. Well, unfortunately, we're going to have to skim down. Where were we? Okay. Here's where we are. Yes?
Yeah.
Okay. So again, very complicated in 2021. One thing I'll reiterate though is that in the prescriptive path, you still do have your 3 different options for your insulation: R value, assembly U value, or whole building UA. And so there is a little bit of flexibility still left in there, even though most of what of the code that used to be termed prescriptive is now required. Okay, we'll do this next. But we now have another question here. Again, this should be coming up on your device. We did talk about this, so hopefully everybody got it. But the question is, true or false, the IECC 2009 to 2021 editions allow me to comply with the insulation requirements using labeled R value, assembly U value, or whole building UA calculation, true or false? And I'll give you just a little bit of time to answer this one because I think most people will probably get it. No, not there yet. I might have given away the answer. Okay, well, if you're still with me after that long and confusing explanation of the compliance paths in 2021, try to answer this one. Okay, well, I'm going to go ahead now at this point. So the answer is true. You can still do, if you're using prescriptive compliance, you can still use the labeled R value, the assembly U value, or the whole building UA as your insulation compliance. Those are all still options, despite the fact that the performance paths have become more complicated. Check time real quick. So now I want to talk a little bit about what details are required on the plans. From a plan submittal point of view, the code lays out specific details they want. Now, your local jurisdiction may be a little different. They may say, we want to see this, or they may say, I've heard of some jurisdictions that don't collect mechanical plans at all. But the code has specific things that it says you're supposed to include on the plans. And it's basically everything having to do with energy efficiency. What compliance path you're using, the insulation R values, the window U values and solar heat gain coefficients. If you're doing any area weighted average trade-offs, those need to be included in the details. HVAC design criteria, HVAC and water heating equipment details, any controls, duct sealing, duct insulation, pipe insulation, and then envelope air sealing details. These should all be included in the plans or the notes. So is it that I'm sealing my ducts with UL tape or mastic? Am I, putting a bead of caulk at the top plate or a sill sealer at the sill plate? Am I using house wrap as an air barrier? What's my insulation R values? All of these should be in the plans. Some jurisdictions may not historically have collected this. It's been in the code for some time though, and it really is all of the energy details about the home are included in the plans. Inspections, the code also lays out specific inspections. Again, your local jurisdiction may have a different process, but this is what's in the IECC. The first inspection is a footing and foundation inspection. From an energy point of view, that's when they look at slab edge insulation, foundation inspection, thermal envelope, insulation, windows, and envelope air sealing. That's not the blower door test necessarily, it's visual inspection of the air sealing. Plumbing inspection, they're going to be looking at controls if they're required for your system and pipe insulation. Mechanical inspection, they'll be looking at, they'll want to see your sizing documents, manual J, these sorts of things. Any controls, duct sealing, duct insulation, and also your ventilation system. And then final inspection are going to be looking at final controls that have been added and then also lighting. So these are the inspections that are laid out in code. Again, if your code official comes at a different point and says, this is what I'm inspecting, then that's what you're going to go with. But this is how it's described in the code. Now, this section of because we're talking about plans, this section of a set of plans brings up an important point of view, and it will show how the code has changed as far as what you can do. Addition to addition now in the 2021 code. So on the left here, we have a plan set that details slab edge insulation, and it's a monolithic slab in both cases. On the right hand, we have some insulation that's attempting to perform as slab edge insulation, but as you can see on the right, it doesn't come to the top of the slab edge. So there's no actual thermal break there. If I'm standing on that floor with my socks on in the winter, my feet are going to be cold because the heat from my body is going to move across that slab and to the outside. There's no thermal resistance because the insulation isn't doing anything in that case. In fact, they might as well not even put it in as opposed to how they did it. On the left, you see a thermal break because they put it continuous on the outside. Now, if you had a different type of slab where you can actually bring the insulation detail up on the inside of the slab edge, that's another way to do it. But in a monolithic board, your only option to create a thermal break is to do it on the exterior. The problem with that is some builders don't like to do that. So, you know, the one on the right, this builder likes a monolithic slab for structural reasons, whatever, but they weren't doing exterior insulation already. So that's a new detail that they would have to add. So how this builder would comply with the code in the past was they would go to the performance path, one of the performance paths, and they would model this as an uninsulated slab. And again, they might as well just forget the insulation because it's not doing anything. They could comply by adding efficiency somewhere else in the building. And then they have an uninsulated slab, but they've got, but that detail in the code 2018 and earlier was prescriptive, which meant it wasn't mandatory, it wasn't labeled as mandatory, and in the performance pass, you didn't have to do it. In 2021, again, the sections in the table point to that air sealing and insulation table, which now points to the slab edge details. So now you have to do them. So the picture on the right isn't an option in any compliance path now in 2021. You'd really have to do the picture on the left in order to do slab edge insulation. I can't think of any other way that you would do it from an installation point of view. I mean, this doesn't have to go straight down. It can go down and out, but it would have to be exterior because there's no interior break. So that's a way that the code has changed in 2021, and you would need to, on the building plans, detail this type of construction. Otherwise, the plan reviewer will say, well, where's your slab edge insulation? Because you got to put it in. So for how you document things and what reports are required, testing results are required. So blower door tests for envelope air leakage, duct blaster test. And then also there is now in 2021, a requirement for testing of the flow rate of the mechanical ventilation systems. That's new in 2021. It was not required by code before. It was required by Energy Star and some of these above code programs, but not by code. So all of these tests have to be done in the field, and they need to be documented and reported for your final compliance. Manual J and Manual S, these have been mandatory in the code for a while. This shouldn't be a surprise to anyone unless you're just getting into the industry. But the load calculation for heating and cooling and then the sizing calculation have to be done, and they should be included really with the plan submittal, because that's what that's when you're doing your design calculations. If you're doing one of the performance paths, 406 or 405, you're going to want to include a compliance document from the software that does that. For our 406, it's going to be one of the energy rating index, HERS softwares like Ecotrope, Energy Gauge, REMRate, one of these softwares that does this calculation. ResCheck can't do it. ResCheck is free from DOE, but it does a UA calculation. So that document, when you submit your plans, there should be a design model that's submitted showing compliance with the compliance path you've chosen. And then at closing, there would need to be another confirmed field rating that shows this home complies with that performance path. Same thing with 405. ResCheck, it does say it's got simulated performance alternative, but I asked DOE about this, and it doesn't do a full calculation that includes everything that's listed in that section in the code. So ResCheck really just does a UA. Again, these HERS softwares, maybe something like REM Design, which is not a rating software, but you can do some of these calculations. You could do a section 405 calculation. it's important to note that some jurisdictions require approval of the specific software, despite the fact that only a few of them actually do the calculation. For product testing and labeling, we have to document our energy features. So anything like insulation R value, we need to have it labeled on the product. And it needs to be tested, this is important, according to US FTC CFR Title 16. That's a specific federal regulation that talks about R value and how we can label insulating products. If there's a product out there like a paint that's claiming a R value, then you have to look at the details. Did they test it according to this federal rule? And what does that federal rule say about what claims they can actually make? There are also some rules about insulated siding, R value, and what can be claimed there. Testing for whether an insulation is air permeable or not, that will affect where you're allowed to put it in the building. And then windows have to include NFRC sticker, and it has to be tested for NFRC 100 and 200 for U value and SHGC. Those are required documents that you should be keeping documentation on your insulation and window products. Again, you know, the packaging should be there. If the bat itself or the insulating product doesn't have it marked there, look at the packaging and make sure you keep that for the code inspector. The efficiency of the heating and cooling system, those labels are important. And then that NFRC sticker, if you don't have the NFRC sticker, that window is not compliant with the code. If you're doing something like blown-in insulation or spray foam insulation, you should have your documentation that says, okay, this product is R whatever at 14 inches or however many inches you put in. You should be able to document that based on the manufacturer's specification. Same thing with spray foam. You should be able to say, this amount of spray foam is an R whatever it is. And again, if somebody says my spray foam has an effective R value because it air seals, that's not what the code cares about. Air sealing is treated separately in the code from R value. So keep those separate in your mind as you're documenting what the products do. Again, I'll just reiterate the NFRC label. If you don't have the NFRC label on one of your windows, the code requires you to accept default window U values. So for a vinyl double pane window, might even be, you know, argon filled or something like that, the code will only give you credit for a 0.55 U factor. That's worse than the prescriptive code window, 0.3 in a lot of the climate zones now in 2021. We'll go through those tables in another module, but the point is that if you don't document your Windows performance, the code says you have this assumed default value, which is worse than code. And what that means is you have to go to the performance path. You can't use prescriptive path unless it's just one window, and then maybe you can do an area weighted trade-off if you've got some that are better than code and then you've got this one unlabeled window. But if you have all your windows unlabeled, you might get kicked into the performance path and have to use that and make up for that energy somewhere else, despite the fact that your window might perform just because you don't have that label. All energy code, all homes that have been built and comply with the energy code should have an energy code certificate. See kind of a small one down on the right there on the breaker box. The code says it has to be somewhere in the utility room, furnace area, or an approved location. So there's not always room on the breaker box. In fact, the code specifically says it can't cover up anything else important. But there are a few different options for where you can put that certificate. It is mandatory in all the codes except for 2021, where it's just required now for everything. But that certificate really looks a lot like the details for what we have to have on the code plans. It's just got to be a lot smaller because it's not going to be a big plan set. But R values, window, U and SHGC, your envelope and duct leakage results, everything about your appliances, the efficiency. If you've got a solar system, what are the details there? How's it tilted, oriented? What's its capacity? If you've got an energy rating index, what's the score there with and without PV, what compliance path you've used. If you do something like, you know, you're doing a blower door test and your jurisdiction allows a guarded blower door as opposed to unguarded in, say, a townhouse, it's important to write that on the code certificate, because the homeowner 2 years later has a energy audit by their local utility and they fail the blower door test, and then they wonder why their new home isn't meeting it because they're getting a different number in an unguarded versus a guarded test. And it's kind of a strange situation, but it could happen, and you want to document the testing that's actually done for code. Again, all details have to be on there. This is just a little section of a plan set, and you can see fenestration U factor, skylights, ceiling R value, basements. These are just the insulating factors here. And then if you look at this section of the plans, you have things like Tyvek as a house wrap. It says Tyvek installed as an air barrier. That's important if it's being used as an air barrier. You know, that's just a product, a house wrap product. That's just what the plans say here. So that's why I'm reading it. Says what kind of insulation, says whether it's paper faced or not. All of these details should be called out on the plans. They're often not in a lot of plans that I've seen. There's structural, and you can see there's insulation there, but there's not a lot of detail. And so it's important to note that those are required. So we have one last question here, and I'll do that. We have maybe 4 minutes left, it looks like. So if you're still with us, which of the following is required on building plans for energy code compliance? And there are a number of options here. So if you could fill that out, we'll see who gets it right. I'll give you just a few more seconds here. Okay. Well, we got, everybody said all of the above, and then one person also marked the other options. They're all correct. Yes, all of these have to be included in the plans. And then I have one more thing. I'm going to put my contact information up here, although you can certainly get it from IBA. But I want to bring up, as we have just a couple minutes left here. And Aaron, if we do have any questions as I'm bringing this up, please feel free to just call them out. But I want to show real briefly some of these plan details here. So again, on this set of plans, we have, very similar to what I just showed on the slide, all of the insulating values are listed really right up front, which is important. I would really want to see the compliance path here too. It has a climate zone written. This is specifically pointing to the insulation tables. So I'm assuming it's probably prescriptive compliance. There are a number of places throughout the code where there are notes that have to do with the compliance path. So here, or with energy code, excuse me. So here we have gypsum board cover and casing at the attic access. Really, this should call out the fact that I want to have a gasket here or something to seal that attic access hatch. Can't be caulked because you want it to be able to move. So a gasket is typically how you're going to see that done. And I want to see that kind of detail on the plan set itself. If I go down to, say, the wall intersection here, I see that they've got zip sheathing. So that's being used as their air barrier. I would want to see some detail there about taping, because you're going to want to have it taped if it's actually going to be an air barrier. So I would want to see that there. I would want to see details about up here at the top plate, again, some sort of sealant there, defining where that air barrier is for me. I know that the sheathing here, the zip sheathing, is being used as an air barrier. So I'm going to want to be able to find, if I'm doing a plan review, that the air barrier is continuous and that they've sealed these spaces where there's typically a lot of air leakage and where the code specifically calls out. So they do have sill sealer gasket at the sill plate. That's an important detail that I want to see there. And so all of those details need to be on the plans. And I'm going to, I think, cut it off. We could do a whole thing on plan review, but now that we're at end time, I'll just ask Aaron if you have any final questions before we stop. I hope you've enjoyed it. I really hope that we'll see you in these later modules where we get into a lot more of the details on the science and the specific requirements. If you do have questions, please feel free to reach out to me afterward if you didn't want to ask them on the webinar itself.
Great. Joe, a question that came up is, you showed that plan set, but one thing that might be helpful, do we have a optimized plan set from DOE or Newport Partners that we could kind of share with the audience to say, hey, as you think about moving forward, this is really the idea, the ultimate plans?
Yeah, I have and this one, the one that I showed, had a lot of what you would want to see. Yeah. I do have another set that I can share, and it was specifically written to show what I think would be optimal at these different locations. I won't say it's perfect, but optimal. Yeah. However, it's specific to climate zone 4 because it was done as part of an effort in Maryland. Yeah. So just with the caveat, we can share with the caveat that people might not find their insulation requirements. And it was done back in 2015. So of course the code is different as well, but conceptually it's showing what we want to show. And so, yeah, I'd be happy to share that, and Eva can post it as a resource or something like that. That's
fantastic. Joe, I want to thank you for joining us today. I learned a ton today. I look forward to the next 7 modules.
Great. Thanks, Aaron. Thanks, Nancy.
Thanks, everyone.
Thanks, Joe.